Hi everybody. So it's been a while since I've jumped on and made a video for you guys, so it seems kind of strange. Hope everybody's doing well. Um, so I kind of wrote down some things here to be aware of before I start and answer all of your questions. I'm going to answer all of your questions just starting at number one all the way till the end. There was a lot of questions, which is fantastic. I'm glad that we jumped on and answered questions, and thank you for that. That's the way that I'm going to take your attendance tomorrow. Um, so yeah, um, so feel free, you do not need to listen to the entire video. Feel free to fast forward to whatever question you have, or other questions that maybe you didn't ask but you want to listen to. I'm assuming this is going to be a pretty long video. I'm probably going to go through about 75% of the test review, okay? If I go through and answer any questions and it didn't answer your actual question, tomorrow I'm going to be on Google Meet every Friday from 8:30 to 9:30. I will be on Google Meet. I will that's part of my office hours. I will always be checking my email during those office hours. Um, but on Friday, I will be checking my emails as well as being on Google Meet so that you can just hop on, ask a question, hop off type of thing. Okay, and I'm going to use the code loopers math every time that I jump on. Okay, that's going to be for both of my classes, for my math 2 and my math 3, just so I don't have to hop on two different office hour Google Meets. It'd be too difficult. Okay, so just so you know. All right, so the test is on Monday if you're in periods 1 and 7. The test will be on Tuesday if you're in period 8. The test will be much shorter than what you are used to. It was supposed to be a two-day test, 50 minutes each day. So obviously it's not going to be that. It's also not going to look necessarily the same. There will be some multiple choice questions, some true false questions maybe. I haven't actually written a test yet because I haven't decided what I'm going to use to do it. I do know that you guys will get a code and I will email it to you. Okay, so on Monday during period 1, I will email you the test right at the start of the period. So make sure that you are ready to go. You check your email, you click on it, you take it, and then you have an hour and 10 minutes. If you do not take it in that window, it will be marked as incomplete. So if that is a problem, you need to make sure that you email me and let me know. Okay. Um, and then during 7th period, same thing. I will email you the link right at the start of 7th period. And then Tuesday at the start of 8th period, I will email you guys the link as well. And then it'll be closed at the end of the period. Okay. You guys are all going to get different codes. You're all going to get different versions of the test. I want to make sure I remind you guys that um, Dr. Healy, the superintendent, sent an email out to you and your parents talking about academic integrity. Okay, it is your integrity that you guys are taking the test, and it is yours. So obviously, I hope that that is the case. Okay. All right. So let's start. Oops. Sorry about that. All right. Like I said, I'm going to start with question 1. All right, so we're hoping my battery doesn't die before I get done with this. Question 1, we want to find the inverse and restrict the domain if possible. Remember, we only need to restrict the domain when it's a quadratic function. You do not need to restrict the domain unless it was raised to the 4th, to the 6th, but we only did it raised to the 2nd just for this year. All right, so just like in 1 and 3, you want to make sure you switch the variables first. So instead of y, I'm going to say x equals 1/3 times y minus 8 squared minus 1. Okay, so every time that you find inverse, you switch the variables and then solve for the other variable. So we're going to solve for y. I have to add 1 first. So you always want to move the constant. Okay, I do not want to take the square root here first because that's not being square rooted. So I'm going to take this whole thing. I'm going to multiply it by 3, which means I'm going to take this whole thing and I'm going to multiply it by 3. I do not need to distribute. I can if I want to, but I don't need to, so I'm just going to leave it like this. That's going to leave me with y minus 8 squared. Since the whole thing is being squared, I can undo it by square rooting. Okay, which is going to leave me with 3 times x plus 1. And the square root of that equals y minus 8. My last step is to add 8 to both sides. And because that's going to leave me with y, that means that then I want to use the notation and say the inverse of x equals the square root of 3 times x plus 1, and then my constant of plus 8, which should be at the end. Okay, that is a totally acceptable answer. The other way that I could write this is I could distribute it, which is probably how I did it on the answer key. And I probably wrote it like this, plus 8, but these are the same thing. It's just a matter of distributing and not distributing. Okay, next question here. I'm going to go through all these graphing questions. Somebody had a question on each one. So graph the function. Remember, if you want to graph this function, one of the ways that you'd want to start it is by identifying the asymptote. Remember, logarithmic functions have asymptotes that are vertical. Okay, so because it's vertical, I want to look at x. So opposite of 5 is negative 5. So that means that's going to be my asymptote. So that's a good way to start. That way, when I start graphing, if I cross this, I know I messed up. So there's my vertical asymptote. Okay. I'm going to rewrite this using y. So I'm going to say y equals, notice I'm not changing the variables because I'm not doing inverse. So I'm going to say y equals log base 2 of x plus 5. Again, do not switch the variables. There is nothing on the outside over here, a constant, so I'm going to rewrite this. I'm going to, remember, I always go down, back up, and around. So that means that this would be 2 to the y power equals x plus 5. My goal is to get the x by itself. So I'm going to subtract the 5 to the other side. Okay. That means I'm going to get 2 to the y power minus 5 equals x. And this is what I wanted. I got x by itself. That means that I can create a table of values. But remember, I'm going to input in for y. I want to input values in for y like 0. I want to do 2 to the first. I want to do 2 to the second, maybe 2 to the third. I want to do 1 negative. Okay, so now I'm just going to substitute in. So 2 to the 0 power is 1, minus 5 is negative 4. 2 to the first power is 2, minus 5 is negative 3. 2 squared is 4. 4 minus 5 is negative 1. 2 to the third power is 8. 8 minus 5 is 3. I'm going to see if this next one fits. I'm going to go 4. So 2 to the fourth power is 16. 16 minus 5 is 11. So it's not going to fit, but I could still graph it. It's pretty close. 2 to the negative first. Remember that if I say 2 to the negative first, I want to ignore the negative first and just say, hey, 2 to the first is 2. But the negative, oops, means that instead of it being 2, I flip it and the answer is 1/2. So it's the reciprocal of the answer. Okay, so now I'm going to graph these and see if I do approach this asymptote. So let's see. I have 1/2, negative 1, negative 4, 0, negative 3, 1, negative 1, 2, 3, 1, 2, 3. Oh, I'm sorry. I'm like, this is definitely wrong. I'm sorry. I'm going to erase this right here. This one I forgot to subtract 5. So that was the 2 to the negative 1/2, but then I have to subtract 5 from it, which makes this negative 4.5. So that would have been negative 4.5, negative 1. So it would have been right here, which is good. It means I'm approaching. I didn't touch. I still need to graph 3, 3. See, 3, 3. And 11, if I wanted to, I could graph 11. 4 would be right there. So this function will look like that. Okay. All right, let's try it with the natural log. This one you're going to need your calculator for because the base right here is an e. Okay. So the first thing I want to do is I want to move this constant over. I add 4 to both sides. Remember, that's a y. So I'm going to say y plus 4 equals the natural log of x minus 2, and the base here is an e. There is no more constant, so now I can rewrite it like this. I always move that constant first. So I'm going to say e to the y plus 4 equals x minus 2. And then I want to add 2 to both sides. Okay, so that's going to be e to the y plus 4 plus 2 equals x. And that's what I'm going to use to create my table of values. Okay, In those table of values, I can just use my calculator for at this point. So like if I said X and I said Y and did this, I'd want to pick Y values because I'd want to make that a 4 first or a 0 first. So I'd start with like -4. And then I'd say -3, -2, -1, 0, because notice then that that's keeping this positive 0 plus 4. I could also do a -5. -5 plus 4 is -1. Now I'm raising to a negative power. And then I can just use those values and put them into my calculator. Okay, so to use the calculator, I would just I'd hit the second button here and this E. And I would say e to the -5th. And then I would say, well, I'm just actually going to do this. -5 plus 4 is -1. So I would say to the -1st plus 2. And then I would just round this and say that this would be about 2.37. I really could just round it to 2.4. Okay. And then I can continue that. I'm not going to go through that right now, but I could continue that. Actually, let me pause it for a second and I'll get the values. Okay, so those are the values that you get, and I stopped once I got to 9.4 because it's going to fall off my graph. Because this is a natural log just like the last one, it's going to have a vertical asymptote, which will be at x equals 2 because of this right here. Oh my gosh. Okay, so x equals 2 would be right here. And then notice if I plot my points, I will approach it but not touch it. So let's see, 2.37, -5 would be about here. 3, -4. So something like this. Okay. All right. Next graphing question. All right. In this one, you want to move this right here first because it is a constant. Don't mistake it with this. Okay. It does not have parentheses around it. It is a constant. So the first thing I want to do is I want to add 6 to the other side. So that's going to give me a y plus 6 equals log base 1/3 raised to the x power. Okay, now I can raise, so I'm going to start from the bottom, work myself up and around. And I'm going to say 1/3 to the y plus 6 equals x, and this is what I wanted. X is by itself. I can create a table of values. Okay, my asymptote, because there is nothing in parentheses, this has not been shifted left or right. This has been shifted down 6, but that doesn't affect the vertical line. So that means that the asymptote is at x equals 0. It means it did not move. It starts here. It's just a matter of whether we move it or not. Okay. So I'm going to put values in here. I want to start with a -6 because that's going to make that a 0. I like to start with making this a 0. So I'm going to start with a -6. Typically, I want my exponent to be positive because it's easier to raise to positives. But if I raise it to a negative power, that's going to take that 1/3 and flip it and make it a 3. So I actually want to raise to negative powers. So I want to make this then a -7 because then that'll raise that to the -1st. I want to make this a -8 because then this will raise this to the -7. Okay, and then I can also put in 1 that I know is going to give me a negative. So let's try this. If I raise to the -6, that'll make this a 0. 1/3 to the 0 power. Remember, anything to the 0 power is 1. All right. If I raise to the -7th, that would become -1. That means that would be 1/3 to the -1st power. Oops, first power. That's the same as saying 1/3. Oops. That's the same as saying 3 to the positive first. Because if I flip 1/3, it becomes 3. So that means that this would be 3. Okay. 1/3, if I raise this to the -2nd, that would be right here. So again, the negative flips this, which makes it 3 to the positive second, which makes this 9. I don't need to go any further. If I do to the -5th, that's going to be, let's see, -5 plus 6 is 1. 1/3 to the first power is 1/3. Okay, so that's enough points. I can graph those. So let's see, 1/3 -5. So 1/3 -5 would be about here. 1 -6. 9. Okay, and because of this asymptote, me drawing it in, I know that when I go this direction, I want to approach this, but not touch it. So my function will look like that. All right. In this next one, graph the inverse of the function. So if we think about the first three problems, the logs and natural log functions, we converted them into exponential so that we could make a table of values. We didn't want it to be a log. So even though the inverse would change this into a logarithmic function, I don't want to make it a log function. Okay, so what I'm going to do is I'm going to create a table of values because it's already exponential. So I'm going to say, okay, my table of values is xy. Notice that I'm going to input in for x this time, since that's an x, not like over here where it was a y. Okay, so picking my x values, I'm going to start with 1 because 1 minus 1 is going to be 0. And then I want it to be a 2 because that'll give me a 1 up here. I want it to be a 3. I want it to be a 4. I'm going to go backwards and do 0. Okay, so I'm going to start with 1. So that'll make this 0. 2 to the 0 power is 1. And 1 minus 7 is negative 6. If I raise this, let's see, if I input 2 in, 2 minus 1 is 1. So 2 to the first is 2. Minus 7 is negative 5. 3 minus 1 gives me 2. 2 squared is 4. 4 minus 7 is negative 3. 4 minus 1 is 3. 2 to the third is 8. And 8 minus 7 is 1. And I'm going to keep going since it looks like I still have room. 5 minus 1 is 4. 2 to the fourth is 16. And 16 minus 7 is 9. So that one still fits. All right, 0 minus 1 is negative 1. So that means this would be 2 to the negative first minus 7. 2 to the negative first is 1/2. Minus 7 gives me negative 6 1/2. Okay. So I'm going to plot these points. Let's see, 0, negative 6 1/2. 1, negative, oops. 1, negative 6. 2, negative 5. 3, negative 3. 4, 1, 5, 9. Okay, I need to know where my asymptote is at. Remember, this is now an exponential function, not a logarithmic function. Oh my gosh, I'm sorry. I'm going to erase all this. Totally forgot about the bold part. We're graphing the inverse. Sorry. The inverse means that I actually don't want these table of values. I want the inverse of them. So that means that instead of it being 0, negative 6 1/2, I want to flip them so that it's negative 6 1/2, 0. And so that it's negative 6, 1. And so that it's negative 5, 2. And so that it's negative 3, 3. And then I ran out of room. And so that it's, let me move this. Negative 3, 3. And so that it's 1, 4. And so that it's 9, 5. So I just took each of these and I flipped them. Okay, remember, inverses means that x becomes y and y becomes x. These were the coordinates that were giving me an exponential function, but I don't want that. I want its inverse, which is a logarithmic function. So when I flip these coordinates, now I graph them. So that means now it would be negative 6 1/2, 0. So right here, negative 6, 1, negative 5, 2, negative 3, 3, 1, 4, and 9, 5. I do need to know where this is at. This inverse function, remember that was going to be the asymptote. It was going to be at y equals negative 7. But now it flipped, which means it's now going to be at x equals negative 7. So it's going to be right here. So my function will go this way, and then it will go down that way. Okay, so that's a tough question for sure. It takes a lot of understanding of the flipping back and forth. It's just kind of, I mean, you can see it got me until I started graphing. Okay, so just take your time with it, read carefully. All right, on to the next page. Got a lot of questions on these, but I don't think they're going to take nearly as long. It says, what is the equation for the asymptote for the function? So it kind of came up in the graphing, or it did come up in the graphing. Because this is a logarithmic functions always have vertical asymptotes, always have vertical. Vertical are x equals, so x equals. Because we're talking about x, this is where x is, this is where y is. So x equals -11 would be the vertical asymptote. Okay. Um, and then actually I'm going to jump to 13 because these two are opposite questions. And number 13, what is the equation of the asymptote for this function? Notice this is not logarithmic, it's exponential. Exponential have horizontal asymptotes. Horizontal asymptotes, which means they're always y equals. And because it's y equals, it means I'm looking for this value out here. So that means it would be y equals 10. So this function would have a horizontal asymptote up here at 10, whereas this function would have a vertical asymptote over here at x equals -11. Okay, all right, back to number 12. What is the range of the function? So in order to figure out the range, which is your height, you would want to know what the asymptote is. So back to number 11. Because it's a log, it will be x equals, and opposite of -19 is 19. So if we graph a sketch of that, we would go all the way over here to 19, and it would look like this. Okay. The logarithmic function, everything that we have done has been on the right side of this. So it's going to look something like this. Okay. It would either look like that, or it would look like this without actually graphing it out, knowing what it would look like. It could look like this on the other side, or it could look like this on the other side. It really doesn't matter what it looks like. When we know what that asymptote is, it's actually not affecting my range at all. My range is going to go from -infinity to +infinity, meaning all the way down here. They will all reach down here. They will all reach up here. So they all go all the way down, all the way up. So this is my range. What this asymptote is affecting is actually the domain. We would have to know which one of these the domain is. But we're not looking left to right, we're looking down to up. So good question, whoever asked that. Let's see, rewrite each expression in exponential form. Okay, in order to write an exponential form, you need a base. So natural log, remember, always has a base of e. So we would write it like this. We go down, we go up, back around. So it would be e to the t power equals c. Now it's an exponential form because it's got an exponent. Okay. All right, the next two questions have to do with condensing. Remember, when we condense, we have to look at the operation. Remember, addition is multiplication, subtraction is division, and these go both directions, depending on whether we're expanding or condensing. Okay, so those were the big rules. And then we also had the rule that an exponent was a coefficient, meaning if we have something like log of x to the third, that's the same as 3 log x. Okay, so let's go through these. You want to work left to right, so I'm going to deal with this part first. So since they're all log base 3, I can condense this. I can shorten it. Okay, I think it's redundant to say log base 3, log base 3, log base 3. I can say log base 3 once of an expression. That's what I'm trying to get at. So this part, I'm going to say log base 3, and if I condense the 5 and the x, because this is addition, I can condense the 5 and the x with multiplication, which means 5x. And then minus 2 log base 3 of y. Okay, this 2 has to come up first. So this would be log base 3 of 5x minus log base 3 of y squared. Okay, you always have to move that coefficient up first. All right, now what can I do with this 5x and this y squared? Because this is subtraction. Subtraction means division. So I would do log base 3 of 5x divided by y squared. And nothing can be simplified in here. If this was a y, I could, but it's not. So this would be my final answer. All right. Over here, I have addition. The first thing I want to do is actually look at my coefficients. I have a 1 here, so that doesn't matter. I do want to move this back up, and I do want to move this back up, so I'm going to start with that. I'm going to say log 12 plus log of x to the 1/2 plus log of y cubed. Okay. Notice that all of these are addition. Since they're all addition, it means that I'm going to combine this, this, and this, all with multiplication, which I can do all at once since they're the same operation. All right, so I'm going to say log, and I'm going to multiply all three of those things together. And it's actually already in order. It's a number, then a variable, then a variable. So that means it's 12x to the 1/2 y to the 3rd. And that would be my final answer. I could also write this as log of 12 square root of x times y to the 3rd. Remember, anything raised to the 1/2 is the same as the square root. Okay. And then nobody asked about number 21. Let's go to expanding. Okay, expanding. You want to break apart pieces. Whenever you have numerators and denominators, always break that apart first. So I'm going to break the top from the bottom. Since it's division, I break it up with subtraction. So that means it'd be natural log of 5x to the 3rd y to the 4th minus natural log of z. And every time we break something up, there needs to be a natural log of it, or log, depending on what it is. Okay, in this case, natural log, because that's what was in the problem. All right, so this part's already broken up, but I can break this part up. Notice that I have 1, 2, 3 things being multiplied, so that means I'm going to have 3 more logs. So I'm going to say natural log 5. Since it's multiplication, it's going to be plus natural log of x to the 3rd plus natural log of y to the 4th minus natural log of z. I can break this up even further because this can go down as I expand. So natural log of 5 plus 3 natural log x plus 4 natural log y minus natural log z. Okay, and order is not really that important when we expand and condense, so I don't need to do any rearranging. That's totally fine. All right, let's try again over here. Again, same thing with this breaking up of the numerator and denominator. Since there's nothing out here where it's like being cubed, where I'd want to bring this down, I want to break up the numerator and denominator. So I'm going to say log base 5, and I'm going to rewrite this using an exponent. So it's m squared n, and this whole thing is being raised to the 1/3 power. And then it's going to be minus log base 5 of p to the 6th. Okay, I'm going to move this out in front, so that's going to be 1/3 log base 5 m squared n. Okay, and then minus, I'm going to bring this 6 out in front, so minus 6 log base 5 p. Okay, I still have some work to do. I need to break up these two, so the m squared and the n. Okay, so in order to break those up, because it's multiplication right here, I have to do it with addition. So it's going to be 1/3 log base 5 of m squared plus log base 5 of n. And notice I'm putting parentheses around this because it's 1/3 times this whole thing, so it needs to be 1/3 times this whole thing. This part's already done, so 6 log base 5 p. All right, now I still have some more work to do. I need to distribute this 1/3 to all of this. Okay, but what's going to happen right here is this 2 needs to come out in front of this. Okay, and actually I'm going to show you that in a second. So let's just distribute this 1/3 first. So that means this is going to become 1/3 log base 5 of m squared plus 1/3 log base 5 of n minus 6 log base 5p. All right, and then like I said, this needs to come out in front, so it needs to come down here. When it comes down there, it's multiplication, so it means I'm going to multiply 1/3 times 2, and 1/3 times 2 is 2/3. So it'll be 2/3 log base 5 of m plus 1/3 log base 5n minus 6 log base 5p. So that was a long process. That's probably the longest way that I can go through and explain this, but by writing out each and every step, it usually makes more sense. Less likely to skip mistakes and seeing that I haven't seen you guys in a long time and it's been a while since we've done this. I don't want to skip any steps in there. Okay, so feel free to rewind and listen to it again if you need to. All right, continuing. Simplify each of the following without a calculator. Okay. So I can simplify each part of this and then go back and add their results. So I'm going to figure out what log base 2 of 8 is. Okay, and this is without a calculator. So that means that I would want to say 2 to the what power equals 8. And I'm going to write this out just so you guys can see. So if it's log base 2 of 8, remember us doing this. So that's where we're saying 2 to the what power equals 8. And that would be 2 to the third. Over here, I would say 2 to the what power equals 4 raised to the x. And I can get these to be the same base. So I can say 2 to the what power equals 4 is the same as 2 squared raised to the x power. Notice they have the same base now. So we're saying 2 to the what equals 2 to the 2x. So that would mean that this would have to be 2x. I want to add those results. So that means that I would be saying 3 plus 2x. So I can either say 3 plus 2x, which is fine, but typically we always write variable first, so 2x plus 3. Okay. All right. Evaluate. All right, so number 29, we'd be doing this, and we'd be saying 3 to the what power equals 81. So 3 to the what power equals 81. In order to do this without a calculator, we'd want to say 3 to the what power. We can rewrite 81 as 3. And remember, when you think about 3, you have 3 to the first, 3 squared, 3 to the third, 3 to the fourth. So these are things that you should know, but maybe you forgot. So this would be 3, this would be 9, 27, and 81. So that means 3 to the fourth power is 81. So then you can see 3 to the fourth power equals 3 to the fourth power. So that's evaluating. So log base 3 of 81 is 4. Okay. All right, over here, we can do this a couple different ways. We can combine. We could also just evaluate separately and then go back and add them. I'm going to, doesn't really matter which way. I'm going to condense them just because we haven't done that in a while. So this would be log base 4 of 8 raised to the second power if I bring this up. None of these numbers are going to get big. I'm gonna probably do it the way you guys did, which is separate. So I'm going to evaluate these separately, much like I did in 27. Okay, so if I evaluate this and this, I can go back and add their results. All right, so let's see. I do want to bring this up, so I want to make that log base 4 of 8 squared, which means then if I rewrite this, I'd be doing this, and I'd be saying 4 to the what power, 8 squared is 64. So 4 to the what power is 64, okay, which you may know. But you also could rewrite this and say 4 to the what power equals 4 and then say 4 times 4 is 16, 16 times 4 is 64, so that'd be 4 to the third. Could also rewrite it with 2's. All right, so that means that this answer right here is 3, okay, from this. Over here, I'm going to say log base 4 of 16 to the 1/2. I'm going to bring this up. Remember, anytime you do the 1/2, it's taking the square root. So this would be the same as the square root of 16, which is 4. Remember, anytime these are the same, the answer is 1. But if you didn't remember that, you can always do this, and you can say 4 to the what power is 4, which has to be 1. So then this would be 3 plus 1. So the answer of this is 1. So the overall answer is 4. Okay. In the next one, I'd want to go like this. And I'd want to say 4 to the what power equals 1/8. I want to make these have the same basis. So the 4 I can say is 2 squared. So that would be my 4 to the what power. And over here, if I make this raised to a negative power, right now it's raised to the first. If I make it to a negative power, so meaning if I said 8 to the negative first, that is 1/8, right? Because the negative flips it. Okay. 8 is the same thing as 2 to the third power. So that's 8, and I want to say 8 to the negative first. Okay, so that means now since their bases are the same, I want to know 2 times what equals negative 3. Notice I'm multiplying. 2 times what equals negative 3. So that means I would divide by 2 and divide by 2. So my answer would be negative 3/2. Okay. Let's see, other question. Solve each of the following without a calculator. Okay. In order to solve this, I'd want to condense this. So I'd want to say log. Because this is addition, I can combine these with multiplication. So I'd want to say 5x times x minus 1 equals 2. This doesn't have a base written in, so that means it's implied that it's 10. So I rewrite this. So once remember the things that I want to do when I solve. If it's a log, I want to rewrite it as an exponential so that it is no more log. So then I would say this is 10 squared equals 5x times x minus 1. So that means 100 equals 5x squared minus 5x. And at this point is where you should go, oh, that's quadratic. I'm going to set it equal to 0. So 5x squared minus 5x minus 100. GCF always makes things easier, so I'm going to divide out of 5, which leaves us with x squared minus 1x minus 20. I can factor what's left. Factors that have to give me a difference of 1. So that would have to be a negative 5 and a 4, which means that x would equal negative 4 and 5. Don't assume that both work or one work or neither works. You want to check. So let's see. Remember, we cannot have logs that are negative. So if I checked the negative 4, that would make this negative 20. You can't take the log of a negative, so that does not work. If I substitute 5 in, 25 is fine, 4 is fine. So x equals 5 is my only solution. Okay. Let's see, over here, I want to get the log by itself first. So I want to subtract 13 from both sides. That's going to give me negative log base 5 of x equals 4. I have to divide by the negative to get rid of that coefficient. So that's going to be log base 5 of x equals negative 4. And then just like the last problem, I can rewrite to get it out of logarithmic form. So that would be 5 to the negative 4th power equals x. Okay. And 5 times 5 is 25. This would be 125, and this would be 625. 625. Okay, but remember when I raise to a negative power, it's the reciprocal of that answer, so it would be 1 over 625. All right, next one. X is already by itself, so I just need to evaluate this and figure out what that answer is. So I don't want to do this because then I'm raising to an x power. So I just need to figure out what this answer is. So that means I want to say 2 to the what power equals 128. Okay, so 2 to the what power equals 2. And honestly, at this point, I would just go, okay, 2 to the, I would say, I would just start doubling it. Go 2 to the first is 2, to the second is 4, to the third is 8. And I would keep doubling these. So if I double it again, it's 16. Double again, it's 32. Double again, it's 64. Double again, it's 128. And there's my 128. So this was to the first, second, third, fourth, fifth, sixth, seventh. So that would mean that x is 7. And that's how I would approach this without a calculator, right? Because that's what we're trying to do. Okay, next one. All right. In this case, I want to get the bases to be the same. 25 is the same as 5 squared. So there's my 25. 125 is the same as 5 to the third. But in order to make it 1 over 125, I need to raise it to the negative third power. And then raise to the x plus 6. Okay, remember this right here is multiplication. So I need to distribute this to both, which makes this 5 raised to the, let's see, 2 times 3 is 6 minus 8x. Over here, when I distribute to both of these, I get negative 3x minus 18. Notice the bases are the same. That was the whole point of rewriting, so they don't matter anymore. So I just want to know when is 6 minus 8x equal to negative 3x minus 18. And this is just a linear function. So I'm going to add 3x to this side, which gives me negative 5x. I'm going to subtract 6 over here, which gives me negative 24. I'm going to divide by negative 5. So if I divide this by negative 5, I get that 24/5 is my final answer. Okay. Let's see. In the next one, I have lots of log base 2s. What I cannot do is I cannot do this and go, hey, look, they all cancel. Okay, I can't do that because of this addition sign right here. So what I'm going to do first is I'm going to condense. I can condense this left side down. So since they're both log base 2, I can, with these two expressions, multiply since I'm adding together. So that means it would be log base 2 of 2x plus 13 times x equals log base 2 of 2x plus 6. And now, because both sides have a log base 2, I can say, okay, that doesn't matter. I'm doing the same thing to both of these expressions. Okay, and then I can distribute here. This is going to give me a 2x squared plus 13x equals 2x plus 6. It's quadratic, so I have to set it equal to 0. So that's going to be 2x squared. If I subtract 2x, I get 11x. I subtract 6, I get 6. Unfortunately, no GCF, so it's going to have to be a 2x and an x. Let's see, I'm thinking factors are 3 and 2. Remember, a 2 cannot go here. If I did, now it's got a GCF that I could divide by 2, so that doesn't make sense. So if it is a 3 and a 2, it would have to be in this order, which, let's see, because this is a minus sign, one of these is plus, one of them's minus. So difference of the numbers. This gives me a 4 and a 3, and the difference is 1. So that does not work. So now I'm thinking 6 and 1. Remember, a 6 cannot go here because now it has a GCF. So that would mean the 6 would have to go here and the 1 here, which this will work. This will give me a 12, which I want to be positive so that I can take 1 away to be 11. this gives me 1/2 and -6. Okay, I want to check both of my answers. If I substitute 1/2 in, this would give me positive. If I substitute 1/2 in, positive and positive. If I substitute -6 in right here, it's negative. So, does not work. My only solution is 1/2. Okay. All right. Next one. Let's see. I would combine these first. These are like terms. So that's a 1 right there. And if I have 1 natural log of x minus 3 natural logs of x, that would mean I'd have -2 natural, oops. That would mean I'd have -2 natural log x. Okay, that's the same thing as saying 1x minus 3x, just with a natural log. Okay, so what that would mean, I'd want to rewrite this, and I'd want to pull this up. Okay, and actually, I don't have to do that, so I'm going to avoid that step. Because this is a coefficient, I can divide both sides by it. So divide by -2. That's going to give me 0 equals natural log of x. Remember, your base here is e. So if I rewrite this so it's an exponential form, that'd be saying e to the 0 power equals x. Remember, anything to the 0 power is 1. So that means that's saying 1 equals x. And there's your solution. Okay, that's one way to do this. You also could break these up into two different, you could evaluate this. Nope, sorry, because the 0 you can't. But you could condense it. So what you could do is you could bring this up. So let's see if I were to divide this. You could say natural log x minus natural log of x to the 3rd power. And this equals 0. And then you could say I can combine these. So I can combine the x and the x to the 3rd with division because of that subtraction sign. So we can say that equals natural log of x over x cubed. And that can be simplified. 0. And we can say that's the same as 1 over x squared. Okay. And then, let's see, I'd want to put an e here, and I'd want to rewrite this. So I want to say e to the 0 power equals 1 over x squared. E to the 0 power is 1, which equals 1 over x squared. And then you could multiply this side by x squared. Multiply this side by x squared. 1 times x squared is x squared, which equals 1. And then you can take the square root of both sides. And this is going to tell you that x is plus or minus 1. But if I were to check the -1, it doesn't work. The only answer that works is 1. So that's definitely the easier way. All right, moving on. Solve. Okay. Notice that there's just one log here. So then I want to rewrite this into exponential form so I get rid of it. So this is going to be 3 root 5, but make sure we square the whole thing. And that's going to equal then x squared minus 4. Okay, this can go to both of those, or sorry, has to go to both of those. So 3 squared is 9, and square root of 5 squared is 5. I'm still multiplying these numbers. Okay, so 9 times 5 is 45, which equals x squared minus 4. Okay, so that's probably what we usually miss is how that becomes 45. We usually want to make this 5 and say 3 times 5 is 15. You have to square both of those numbers. I could subtract this over and try to factor, but since there's only one variable, I'm going to add 4 to both sides. And this becomes 49 equals x squared. So I'm going to take the square root of both sides, and that means that x equals plus or minus 7. I'm going to check both answers. If I plug a 7 or a -7 in here and square it, I'm going to get 49. And 49 minus 4 is 45. This is positive. This is obviously positive already. So that means that both of these answers work. Okay. All right, in the next one, let's see. I'm taking the natural log of this and the natural log of this quantity, which means they don't matter because I'm doing the same thing to both expressions. So that means that this is 1/3 x squared plus 7x equals 3x. It's quadratic, so I'm going to move this over to set it equal to 0. So it'll be 1/3 x squared. If I subtract this, it'll be plus 4x equals 0. All right, you do two things, and I'm going to show you both. I typically like to look for GCF, which means factor out. I would factor out a 1/3 x, which would leave us with an x. Remember, division means how many 1/3s go into 4. So how many 1/3s go into 1? That'd be 3. So how many 1/3s go into 4? That would be 12. Okay, so that's how I would approach it, and then I could check 1/3 of 12 is 4. The other way to do it is you could take this whole equation and you could multiply it by 3. Because 3 times 1/3 would make that x squared. 3 times 4 would be then positive 12x, and 3 times 0, notice I'm distributing it to all 3, would be 0. And then I would factor out an x, which would leave me with x plus 12 equals 0. Notice if I solve over here, I get x equals 0 and negative 12, and over here I get 0 and negative 12. So I get the same answers. Okay, if I check 0, 0 does not work because if I substitute a 0 into here, I can't take the natural log of 0. And if I substitute negative 12 in, I can't take the natural log of negative 36. So since neither of my two solutions work, that means that there is no real solution to this problem. All right, moving on. What am I doing with these? Solve, calculator, okay. Just because it says calculator okay does not necessarily mean you need a calculator, okay? Let's see, you want to condense. So remember, you cannot do this, okay? The reason you cannot do that is because of that subtraction sign. So the first thing we want to do is rewrite, condense. Okay, so I'm going to say log. Because of this subtraction sign, I can divide those. So that would be 2x squared minus 18 divided by x minus 3 equals log 6. Now, because I'm doing log of this, expression equals log of 6, now I can cancel them. So that gives me 2x squared. Actually, I'm going to do yeah, I'm going to write. So that leaves me with 2x squared minus 18 over x minus 3 equals 6. Okay. I could factor this. So let's say I factor the top. That would then give me, let's see, if I factor the top, it would give me x squared minus 9. And then that could be factored further into x plus 3, x minus 3 over x minus 3 equals 6. The x minus 3's cancel. Okay, and that leaves us with then 2 times x plus 3 equals 6. If I divide both sides by 2, leaves me with this. If I subtract 3, it gives me x equals 0. That's one way to do it. You guys remember you can also multiply. So I could multiply by x minus 3 on both sides, and then those cancel. Multiply by x minus 3. All right, some different colors so you can see. So that's going to leave me with then my numerator equals 6x minus 18. And then I can factor it because it's going to be quadratic. So 2x squared. If I subtract 6x over, it becomes minus 6x. If I add 18, it's gone. So when I factor this, factor out a 2x, it would leave me with an x minus 3, which would actually give me two solutions. It would give me 0 and 3. What's going to happen is because I never got 3 over here, that's not going to work. If I notice, if I substitute 3 in here, 3 minus 3 is 0, which can't work. 0 is not going to work either because 0 minus 3 is negative 3. So that doesn't work either. So this would be another one where we have no solution. Remember, any one place that you can find that it doesn't work, it can't work for the whole thing. All right, next one. Okay, these two logs, again, do not cancel them out, but we can condense them just like before. So because that's subtraction, I can divide these. Again, I can do that because that's both a 27 and 27. So that means that this would be log base 27 of x squared minus 49 divided by x plus 7. And then there is no log on the other side, so it just stays 1/3. Okay. I would try to simplify this first. So I can write that as, I can factor it as x plus 7, x minus 7 over x plus 7. And then remember, there's still this log base 27 here, equals 1/3. By factoring, I notice that these cancel. That's going to leave me with a log base 27 of x minus 7 equals 1/3. And now I can rewrite this. So I can go 27 to this power, come back around, and I can say 27 to the 1/3 power equals x minus 7. Okay. 27 to the 1/3 power means that that answer is 3. It's saying what times itself 3 times is 27. So that's where you go, well, that's 3 times 3 times 3. And the 1 means you want one copy of that. Okay. So 27 to the 1/3 power, that's 3 equals x minus 7. So if you add 7 to both sides, you would get 10. If I check to see if 10 works, substitute 10 in here, that's 17, that's 5, or that's fine. And then it would be 100 minus 49, which is a positive number. So 10 it is. All right. Let's see, what do we have here? In order to get at the log, we're going to have to move this constant. So add 9. That's going to give me a negative 8. So move constants, move coefficients. I want to divide this whole thing by negative 2 to move the coefficient. That's going to give me a 4. My goal is to get the log by itself. So because the log, now it's log base of this, now I can rewrite the exponential form. I can say 4 to the 4th power equals x plus 1. So let's see, 4 to the 4. So 4 times 4 is 16. So that's 16 times 4. 16 doubled it. Actually, let's use a calculator here. But 16 times 4 is 64. Should be 256, but I gave you a calculator, so let's make sure. 16 times 4 to the 4 should be 256. All right, so this would be 256 equals x plus 1. I would subtract 1, and then my answer would be 255. Check my answer. That would give me 256, which is positive. So we're good. Over here, let's see. So same idea. I want to move that constant first. So I'm going to add 8 to both sides. So 1.3 e to the negative 6x equals 9. I want to divide by my coefficient. So notice different numbers, but same exact properties, same steps. So that's going to leave me then with e to the negative 6x equals, and I'm not going to divide this because I know it's not going to be a nice number. Okay. Anytime that we want to get at that exponent means that we want to bring it down, we have to use a log. I can use a log or a natural log. In this case, because this is e, I'm going to do natural log. So I'm going to take the natural log of this side and the natural log of this side. Over here, this cancels, just dropping down this negative 6x. Over here, I'd be doing natural log of 9 divided by 1.3. In order to get x by itself, I have to divide by negative 6, which means I divide by negative 6. All right, so I'm going to show you my calculator. I'm going to write the natural log of 9 divided by 1.3 divided by negative 6. I don't have to mess with any ugly numbers until the very end. So that means my answer would be that x is about negative 0.32. Remember, we should be rounding accurately to 2 decimal places. All right, next. There is no constant to move, but I do want to divide by the coefficient here. Do not multiply these two numbers, otherwise you're doing multiplication before raising 18 to a power, and that is not PEMDAS. Oh, oops. All right, so where'd it go? All right, I'm going to divide by -3, divide by -3. That's going to leave me with 18 to the 5 minus x, and this is going to give me an ugly number since I'm dividing by 3. It's going to give me a repeating decimal. So I'm going to leave it, but I do know it's positive. Same thing as before. I don't have an e here, so I can use natural log or log. It does not matter. They're going to give you the same answers. I'm going to use log because I'm guessing that's what most of you guys will do. This means that this comes down, so it will be 5 minus x times log 18 equals log of 22/3. Anytime, if you remember, any time that we do this, the next step will always be to divide, because by bringing this down, I've created multiplication, which means then to undo it, my next step will always be division. So now I will divide by log of 18 and divide by log of 18. Okay, that's going to leave me with 5 minus x equals, I'm going to put this in my calculator. Let's see. So we have log of 22/3 divided by log of 18. So that's going to be about 0.69. My last step, well, almost last step, is to subtract 5. So in my calculator, I have the exact answer. I'm going to subtract 5. That's going to leave me with negative x equals negative 4.31. So divide by negative, that makes these positive. So that means that x is about 4.31. There we go. All right, next page. We're getting to the end. Oh, okay. Let's see, I have a note here because Gemma Lee asked, can you use log instead of natural log? To answer your question specifically, Gemma Lee, since yours was specific, yes, you can use log instead of natural log. I just use log here, like I did in number 54, just because there's less letters, one less letter, not many less, but I want to show you that you get the exact same answer. Let's see. So if I were to put here instead of natural log of 2/7, and I were to put log of 2 divided by 7. Oops, sorry, it helps if I can solve it right. Once you get here, yeah, you would divide by, you move this over this way, so you'd put in your calculator log of 2 divided by 7 divided by log of 0.868. And notice that that gives me 8.85. So yes, you can use natural log or log. They're interchangeable. They have the same properties. You just can't evaluate. In terms of solving, you can choose which one you want to use. Okay. All right. Let's see. So, and then other people did have a question on this, so I'm going to go through the question too. And I'm going to use a log to answer it. So generally, if you're listening, I'll go through and do it with a log. So, cobalt-60 decays at a rate. So decays means it goes down. 700 grams now. After how many years will there be 200 grams of cobalt-60 left? So there's 700 grams now. So I'm going to start with the formula, which would be y equals a times b to the x. Because we're talking about it decaying, we typically use a times 1 minus r raised to the x. Anytime we have percentages, we use 1 plus or minus r. Okay. So if there is 700 now, after how many years will there be 200? Okay. So if there's 700 now, that would be 700 times 1 minus 13% looks like this, and then I'm going to add a 2 onto it. This is happening each year, so I'm going to raise it to the x power, and I want to know when is it going to get down to 200. This should make sense because it's decaying, and notice 700 is going down to get to 200. Okay, so I want to make sure this makes sense. All right, first I have to get rid of my coefficient, which means I'm going to divide by 700. So I'm going to just write that then as 2/7 equals the 1 minus, let's see, so I'm going to write this in. 1 minus 0.132 is where that decimal of 0.868 was coming from. So it's 0.868 raised to the x power. In order to get this x down or solve it, I'm going to have to take log of both sides. So log or natural log, it does not matter. But this then comes down. So it will be log of 2/7 equals x times log of 0.868, which means then I divide by log of 0.868 divide by log 0.868, and that's where then that answer is coming in. So if I were to do, so it's already in here, then I would get that x is about 8.85, and this was talking about years, so years. Okay. All right, next one. Let's see. Population of Austin. In 1983 was 140,000. If the town has been increasing, as soon as we have percents, we're again typically going to be using 1 plus or minus r to the x power. In what year will Austin reach 200,000 people? So we want to know, when is it going to reach 200,000 people? And let's see, it started with 140,000. Okay, and it's going to be 1 plus 1% is written like this. So then I add a 5 onto it, and I want to know time-wise. Okay, so this is talking about, this is happening each year. All right, first thing I'm going to do is I'm going to divide, just like I did in the last one. So we're dividing by coefficient. I'm going to have a lot of zeros cancel out here. And if you wanted to, if it made you more comfortable, you could do this in your calculator. Let's see, oops, 200, 1, 2, 3, divided by 140, 1, 2, 3. And when you get this, you can change this into 10/7. So then it's a little bit easier to work with. So I'm going to say 10/7 equals 1.015 to the x power. Okay. At this point, I have to take the log of both sides. And remember, when I do that, this comes out. So that's going to give me log of 10/7 equals x times log of 1.015. Anytime, remember, every time we do this, the next step will always be to divide, since we just created multiplication. So divide 0.015. So I'm going to put in my calculator. I can use natural if I wanted to. Log of 10/7 divided by log of 1.015. And I get that this is about 23.96 years. Okay, however, that was not the question. The question was, if the town has been increasing at this rate, what year will Austin reach 200,000 people? Okay, now if I added this to 1983, then it's going to give me a decimal, which doesn't make sense for a year, and it's also not going to be in that year. Okay. So what I'm going to do is I'm going to say 23.96 plus 1983 like I did here. And notice that gives me the year 2006.96. But again, we don't write years like that. But we are going to say the year 2006, which seems odd because we're kind of rounding backwards then. But it is in the year 2006. It's just at the very end when Austin will reach that population. So in the year 2006. Okay. All right, next up. Population of honeybees on my uncle's ranch started with 6 bees. There are now 1,000. If the population appears to be tripling, anytime you see that word doubling, tripling, quadrupling, half, it's got to be a times b to the x power. Since it says that it's happening every 2 weeks and not every week, it's when we make the exponent a fraction. All right, so let's see. We started with 6b's, and it's tripling every 2 weeks. So we would say x divided by 2. Remember, it's always x divided by something. It's never flipped. It's never 2 divided by x. And there's now 1,000. It's a lot. We want to know how long has this been happening. All right, first I'm going to divide by 6. Okay. That's going to leave me with, I can simplify this if I want, but I'm just going to leave it. That's going to leave me with 1,000 over 6 equals 3 raised to the x over 2. I'm going to do the log of both sides, log, which brings this down. So that will be log of 1,000 divided by 6 equals x divided by 2, log of 3. Okay, divide by log of 3, divide by log of 3. Let's see, log of 1,000 divided by 6 divided by log of 3. Okay. I get 4.66 equals x divided by 2. In order to get x by itself, I multiply both sides by 2. So times 2. Notice I'm using the exact answer. So I get that x is about 9.31. And this was in weeks. I don't remember what I asked for. How long has this been happening? So about 9.31 weeks. If it asked for days, I would have to convert it by multiplying by 7. I could do times 7, and then it would be how many days. But this is fine. Didn't ask me for it, so I'm going to leave it in weeks. Okay. Let's see. Vince just checked his bank account. He has $12,000. He started with $5,000, which is awesome. It has been compounding monthly. All right. Remember, as soon as you see compounding, you're looking for compounding continuously or monthly or daily. Continuously has its own equation, and monthly, daily, weekly, all that has its own. So I'm going to start with the formula. It is y equals your principal times 1 plus r over n raised to the nt. Okay, so I'm going to start substituting stuff in. So he has $12,000 now. He started with 5,000. And then it's going to be 1 plus 4% would be this. Then you tack the 8.5 on at the end. Monthly, there are 12 months in a year. And then we need to raise it to the 12 times our time, but that's our question, is how long. All right, so I solve. First step, divide by 5,000. When I divide and bring 5,000 over here, 12,000 over 5,000 simplifies to 12/5. Okay. Yeah, I want to keep this answer exact, so I'm not going to put this in my calculator. I'm going to leave it as 1 plus, it's kind of a pain to write, but it keeps our answer exact. Raised to the 12x. At this point, I need to take the log of both sides, which will bring this down. So that means I will have log of 12/5 equals 12x times log of 1 plus 0.0485 divided by 12. Okay, I need to divide both sides by this. Oh my gosh, for sake of time, I'm not going to write it on both sides. I will put it in my calculator. So I'm going to say log of 12/5 divided by log of 1 plus 0.0485 divided by 12. And remember, you don't need a bunch of parentheses within this. It's going to do order of operations anyways. So just like I put it in is good. All right. That's going to give me 217.05, which equals 12x. So if I want to get x by itself, I need to divide by 12. So I'm going to take this exact answer and divide by 12. And that's going to give me that x is about 18.09. And remember, anytime we talk about compounding, it's always in terms of years, not months like this is, because we said 12 months in a year. Okay. So how long has this money been in this account for? About 18.09 years, not months. All right. 57, Gemily, you had a specific question, so I wanted to start with that. You said, why is it in days and not hours? I think you meant this question. You said 56, I think, on the form, but that didn't make sense for 56, so I'm assuming you meant this one. And I thought I'd start by looking at the answer key. And I don't know if I'm going to answer your question, so feel free to email me if I didn't answer it. This one specifically said after how many days, which is why we converted those hours into days. The problem started, let's see, it started with hours. So when we answered the question, it was in terms of hours. So when we set up the equation and we go through and we find that this x value right here, it was in hours because it was x divided by 10 hours. But then we needed to convert this number of hours into days because it was asking how many days. So I don't know if that answered it. If not, I'm going to go through it right now, and maybe that will answer it. Okay, so let's see. They currently have 34. All right, as soon as you see doubling, remember, start with your formula. Y equals A times B to the x, and in this case, it's going to be x divided by t since it's every 10 hours. All right. So let's see, nearby communities collecting, they currently have 34 that is doubling every 10 hours. After how many days will there be 1 million? So they have 34, it's doubling, and it's every 10 hours. So we're going to do x divided by 10, and we want to know when it's going to reach 1 million. So that's 1,000, that's 1 million. All right, first step, divide. That would give us 1 million divided by 34, which can be simplified, but I'm going to leave it, which equals 2 to the x divided by 10. I want to take the log of both sides. Hopefully you're kind of noticing the repetitiveness of this. Let's see. So that's going to give us log of 1 million over 34 equals x over 10 log 2. So using my calculator, it's going to be log of 1 million, okay, divided by 34, divided by the log of 2. Okay, that's going to leave me with 14.84 equals x divided by 10, which means I need to multiply both sides by 10, which gives me that x is about 148.4. Okay, that answer, though, is in hours. This answer is in hours because it was every 10 hours. The problem is the question was asking for how many days. So that means we need to convert this into days. So in order to convert this into days, how many hours are in a day? 24. So we would divide by 24. So if I notice again, I'm still using that exact answer. So you don't want to clear your calculator out so you're done with the problem. So if I divide that by 24, that's going to give me about 6.19 days. And I can have an approximate day, so decimal is good. Okay. All right, next problem. All right. Generally, you again had a specific question, so I didn't answer that question first. So let's jump. You said, why is it the 67th wedding anniversary, not the 66th wedding anniversary? Because if it takes 66.17 years, that means it happened after the 66th wedding anniversary. So if we said 66th wedding anniversary, it hasn't yet happened yet because it happened slightly after, which means then at the time of the 67th wedding anniversary is when they will have that much money. Okay, so again, think about it as like we don't celebrate a half anniversary. If we celebrate it at 66 years, they won't have it yet. But then at the next anniversary, they will. Okay, and feel free to listen to the explanation. Everybody else, I know, I think I had this question for other people too. So it says Chip and Joanna started an investment with $2,300 that compounds quarterly at a rate of 3.9%. They started the account when they got married in 1979. What anniversary will they be celebrating when they reach 30,000? So I want to know, when are we going to reach $30,000? They started with 2,300. It's compounding, so we're going to say 1 plus, let's see, 0.039, and it's compounding quarterly, which means 4 quarters in a year. And then it's going to be raised to the 4x, since we don't know what the time is. Okay. So we want to figure out how many years. So we're going to divide first. So we're going to do 30,000 divided by 2,300 equals 1 plus 0.039 divided by 4 raised to the 4x. Okay, I'm going to take the log of both sides, which means bring this down. So this will be log, and I can cancel 2 zeros out of both these just for a little bit less writing. So it'll be log of 300 divided by 23 equals 4x log this. All right. I'm not going to rewrite all this again. So I'm going to say log of 300 divided by 23 divided by the log of 1 plus 0.039 divided by 4. Okay, that's going to give me, let's see, 264.70 equals 4x. And you don't need to write this down. It's just a placeholder so that I can see that my next step is to divide by 4. So don't forget about that. That's going to then give me that x is about 66.17 years. Remember, anytime we talk about compounding, it's years. So we want to know, what anniversary will they be celebrating when they reach that much money? Okay, so again, like Gemily was asking, in 66 years, if we were to round this down to 66, they won't yet have that much money. So we're actually going to have to round it up to 67 years. So what anniversary? Their 67th anniversary. Okay. Now, the year in here was totally irrelevant, unless I asked a question of in what year will they have that much money. Then I would say 67 years plus the year 1979. And that's going to give me the year 2046. So, depends on the question. Okay. In this next one, I'm going to go through, nobody asked about E, I don't think. So I'm going to go through option. I'm going to go through A, B, C, D, and then the second D. Sorry, I don't know why there's 2 Ds. Just to kind of get all these. All right, Ryan has a few short-term investment options he's looking into. Determine how much money he would have for each. Option 1, he invests $5,000 that is compounded weekly. All right, so compounded weekly, I'm going to say Y equals, he invests $5,000, 1 plus 361 divided by the number of times it would be compounded. There's 52 weeks in a year, and we would say 52 times 5. Okay, and I'm going to leave that, and I'm going to come over here. Compounded daily means that we would say Y equals, he invests 4,500 times 1 plus. All right, now notice that this is less than 1%. So 1% would go in these first 2 decimal places, so nothing can go there. And then we'd have to write 98 divided by daily, 365 days in a year. We don't worry about leap year. And then we would raise it to 365 times 10. Okay. And then in this next one, so words that you want to pay attention to, we have weekly, we have daily, and then notice this next one switches to continuously, so we have to switch the formula, and it's that PERT, so PE raised to the RT, okay, which you should have had these memorized for the test. You wouldn't have been given a formula sheet. Use that to your advantage for the test that you're going to get in a couple days. By no means is it cheating for you to have the formulas written out. Okay. All right. So the principal is 4,500 times E raised to the rate times 8 years. Okay, and I'm writing all these out so I can go back and put it one time in my calculator. So 5,000 plus, and you're going to want to double check and make sure that you guys can get these answers correct. Putting it in your calculator. 2 times 5. And I'm going to put the next one in too. 4,500. Oops. 1 plus 0.008. 365 times 10 is 3650. Okay, so let's see. I definitely did something wrong in the first one. So I'm going to write this down. So this is about 4963.33, round correctly to 2 pennies. The first one I forgot to divide. 1 plus 0.0361 divided by 52 raised to the much more reasonable answer. So this is about 598871. All right, this one, let's see, 45 times e raised to the 0.0245 times 8. And this one would be about 547,437. Okay, now, typically compounding continuously is always going to give you guys the most money. However, that only works if we start with the same initial value and the same rate, and all of these are different. These two had the same initial but different rates. So we can't assume right away that this one was going to give me the right answer or the most money, which is why I actually made it so that it didn't to point that out. So which one makes the most money option? Okay, again, this one did not because it was different principles and different rates. So then these are not comparable. All right. Part D. What does Part D say? Ryan really likes the third option where his money is compounded continuously. If he was able to negotiate the rate a little, what would he need the rate to be in order to have $5,800 after 8 years? Okay, so we're going to use that formula, y equals PE raised to the RT. So we're going to go based off the information in this problem. So he invests 4,500 times E. The rate is what he wants to negotiate, so that's what we're trying to figure out. And the time is still going to be that same 8 years. And let's see, in order to have $5,800. All right, first we're going to divide, which is going to give us 58 divided by 45, which, and I'm just canceling out the zeros, which equals e to the 8r. So you can use log or natural log. I'm going to use natural log. That's going to give me the natural log of 58 divided by 45, which equals, these cancel and the 8r drops down. Okay, it does not get rid of the natural log on the left side. Okay, so I'm going to do the natural log of 58, and you have to use natural log here. Okay, because that's what we use to solve it. Otherwise, there'd be a log on both sides. So the natural log of 58 divided by 45, and then I'm going to divide by 8 to get that by itself. So that means that the rate would have to be about 0.0317. And notice I'm pulling 4 decimal places here. The reason is because then the rate would be 3.17%. And then I can round my percent to 2 decimal places. Okay. For the sake of the situation that we're in, if you wrote 3%, I'd be fine with that. Okay. Next question. Okay, so you guys might want to pause this and read through the problem first before I start kind of going through it, and then you're confused as to where things are coming from. Because I'm going to kind of just jump into the explanation instead of you listening to me read it. Okay. All right. So in order to figure out the variables, I need to figure out what T is, what the room temperature is, and what the initial temperature is. And that's all defined up here. Initial temperature, room temperature, and T minutes. Okay. Notice though in this question it says that T is measured in hours, which is kind of nice. So we need to make it specific for this question because notice that this formula has been slightly altered from this one. Okay. All right. My T is my time in hours. From 11 a.m. to 6 p.m. is 7 hours. So we're going to say 7 equals negative 5.05 times the natural log of T minus. Okay. And T is what I'm trying to solve for. Okay. The room temperature is where the steaks are sitting. So notice it says the chef takes this 5-pound package of steaks out of the freezer and places them into the refrigerator. Since they're in the refrigerator, that's where the room temperature is, and the refrigerator is 40 degrees. Okay. The initial temperature is what it was when it was in the freezer. And the freezer is 0 degrees. So then it would be 0 minus the room temperature of 40. Okay. So first I'm going to want to divide by negative 5.05. Let's see. So I'm going to do 7 divided by negative 5.05. All right. It does not give me a nice number, so I'm actually then going to, I should know. I'm going to leave it. I'm going to say negative 7 divided by 5.05 equals natural log. This is T minus 40 divided by negative 40. Okay. Since there's only one natural log here, I want to rewrite this into exponential form. The base is e, which means I'm going to do this. Okay. So I'm going to say e raised to the negative 7 divided by 5.05 equals T minus 40 over negative 40. Okay. So I'm going to evaluate that left side. That's going to be e to the negative 7 divided by 5.05, which is, I'm going to come over here, which is about 0.25, which is about 0.25, which then equals T minus 40 over negative 40. In order to solve this, I want to multiply by the denominator. Multiply by the denominator. So I'm gonna keep that exact answer. So I'm gonna times by negative 40, which gives me negative 10 equals T minus 40. So I add 40 to both sides. So, and I can do this without, but I just want to show you. So if I take that answer and I add 40, rounding to 2 decimal places is going to make that a 30. So that means that my T is about 30 since we rounded. Okay. T is measured in hours. Sorry, that was little t was in hours. Capital T, let's see, capital T, if we come back up here, is the temperature. And these were in degrees Fahrenheit. So that means that it's about 30 degrees Fahrenheit. What will the temperature of the steaks be? So at 6 p.m., the temperature of the steaks will be about 30 degrees Fahrenheit. Okay, next one. Okay, so you have a corner. Again, without rereading through this whole thing, we have, so now we're going to use this formula up here where T represents the temperature. And then we also have T sub R, which represents the room temperature. So we have two T's, okay? T, this one right here, is happening after a certain amount of time. This one's the room temperature. So let's see what we have. Coroner's crime scene. Body was in a room with a constant temperature of 65. The body is now 73. Okay, so after some time had passed, the temperature of the body is 73. Okay, and that's equal to, sorry, I need to keep going up to see the formula, T sub 0. So that would be the initial temperature. Okay, we're assuming that the body was a normal body temperature, so that's 98.6 minus the room temperature, which was 65. Okay, and then, sorry, I gotta look back up, e to the negative RT. And that would be e to the negative r, which is over here, 0.001666 times T. And then plus the room temperature, which is 65, which I think was plus, yeah. All right, so we're trying to figure out and assume at the time of death. So how long ago did the person die, which means we want the time. So first thing, I'm going to move this constant over here. So if I subtract 65, let's see, that would be 8. I'm also going to subtract what's in the parentheses, and I'm going to say 98.6 minus 65, which is 33.6 times e to this long decimal, 666t. Okay, I'm going to divide. So 8 divided by 33.6 equals this. At this point, I'm going to take the natural log of both sides, which cancels here. So we're going to get the natural log of 8 divided by 33.6 equals negative 0.001666t. Okay, so using my calculator, natural log of 8 divided by 33.6 divided by that long decimal. See, 0.01666. Okay, and that gives us that T is about 861.40. All right, now we gotta look to see what T is. T is defined as minutes up here, and this is the formula that we used, minutes. Okay, so that would be minutes. Okay, let's see, how long ago did the person die? All right, so nowhere in here did I say anything about units. So if you want to leave it at this many minutes, you can definitely leave it that. If I did say how many hours, which is a more reasonable answer, minutes is kind of ridiculous. We would take that answer and we would divide by 60, since there's 60 minutes in an hour, and then that would tell us that it's also about 14.36 hours. So be prepared to answer either question depending on which unit I ask. All right, we got another one. All right, again, I would pause and read through the problem if you need to. This one's pretty straightforward. The formula is given to you. The only thing that we need to substitute in is this pressure, which is given to you. So we're going to say 87 equals 100 times E raised to the negative A divided by 8. So if I want to solve for A, I need to divide by 100. So 87 over 100 equals E raised to the negative A divided by 8. I'm going to do the natural log of both sides, which leaves me with the natural log of 87 divided by 100. These cancel. This drops down. Okay, it might actually be easier to write it like this. Negative A over 8. It's an A, not an A, a 9. So I'm going to times both sides by 8. Okay, so if I put that in my calculator, it'd be 8 times the natural log of 87 divided by 100, which gives you this. So that means that we would get negative 1.11 equals negative a. Divide both sides by negative 1, and you get that a is 1.11. So what was their altitude? Notice it says altitude is in kilometers right here. So it's 1.11 kilometers. So pretty far. Okay. All right, last page. My battery's at 10%, so hopefully we make it. Okay. Hopefully. All right. Again, read through this one because I'm going to kind of jump into it. All right. So here we go. Let's see. We have north and south. At north, there were 2750. Actually, I'm going to write the year first. North, south. Statistics show that South had nearly 4,300 kids in 2012. So in 2012, there were 2012 4,300 students. Compared to North, with in 2012 having 2750. South has since been declining at a rate of 1.8%, so that means they're going down 1.8%. To North's growth, so they're going up 2.1% each year. At the current rates, what year will North and South reach 3,000 kids? So I'm going to set this equation up because I feel like I've answered a ton of questions at this point having to do with this. So what you would do is you would say 3,000 equals, and let's do North first, so this will be North. They started with 2,750, and they're raising 2.1%, so we would say 1 plus 0.021, and we want to know how many years. Okay. And then we would do the same thing for South. We would say we want to know when are they going to reach 3,000. We started with 4,300, and we are declining. So in this case, we're going to say 1 minus 0.018 raised to the x power. Okay, so we're going to solve these. I guess I can go through this with you. So we're going to divide. So 3,000 divided by 2,750 equals 1.021 to the x power. Take the log of both sides, which brings this down. So log 3,000 divided by 2,750 equals x log 1.021. Okay, check on this battery. That's going to give us, let's see, log of 3,000 divided by 2,750 divided by log of, shoot, I can't read my own handwriting, 1.021. So that's going to give us about 4.19 years. Okay. Same process over here is going to give us about 19.82 years. Okay. So in terms of years, we would say then that North would be 4 years after 2012 would be the year 2016. And South would be 19.82 years, so 19 years after the year 2012, which would be 2031. So about that. All right, last question. It's exciting. This is the longest video I've ever made. Okay. All right, let's see. Half-life of a radioactive isotope. If you have 2 grams remaining and you started with 3. All right. So let's see. So half-life is just like you're doubling and you're tripling, which means you want to use this formula. Okay. So it says you started with 3 grams, so that will be 3. The half-life means the rate is a half. Yeah, is 150 years. So that means that it's getting cut in half every 150 years. So it's another way to say every 150 years, which means we would do x divided by 150. And we want to know, let's see, if you have 2 grams remaining. We have 2 grams remaining in 1960, and what year is it now? Okay, so we want to figure out what x is so that we can go backwards and figure out what year it is now. So I'm going to divide by 3. Gives us this. Okay, I need to take the log of both sides, or natural log. Bring this down. X over 150. Oops, that's a lot more equal signs than I meant. X over 150 log of 1/2. I divide by log of 1/2. Okay, so my calculator, see, log of 2/3. Oops, 2/3 divided by the log of 1/2 or 0.5. So that's going to give me 0.58 equals x over 150. So multiply both sides by 150. I'm using, again, the exact answer that's in there. So again, don't clear until you're done with the problem. So times 150. That tells me that x is about 87.74. And this was talking about years since it was a half-life of 150 years. Okay, now the question is saying what year is it now? Let's see, it said you started with 3 grams in 1916. So if you started with 3 grams in 1916, and it's been 87.74 years, so 1916 plus 87.74, that would mean that it's got to be sometime in the year 2003. So looks like later in the year, but it's all estimate anyway, somewhere in the year 2003. Whew. All right, that was a lot of me talking. I don't know if you listened to the whole thing. If you did, kudos to you, and I hope it helped. I hope that somewhere in there I answered everybody's question. I hope that you can go back and listen to your questions as it gets closer to Monday. Okay, I want to revisit one more time right at the beginning, so in case you have any questions. All right, so things to remember. For this. Your test is on Monday if your period's 1 and 7 at your assigned period time. Okay, if you have a question about that, email me. Your test is on Tuesday during period 8. Tuesday if your period 8 at your assigned time. I'm not going to be sending you the link until it is your class period. Each period is going to get a different link. Okay, so no sharing of links because it's not going to be the right test, and then it's going to be wrong. Okay. Um, so look for your link and the instructions to tell you how to take the test. What you'll do is you'll get a link, you'll get a passcode, you'll log in with your student ID most likely, and then that will take you into your specific test. Okay. It will have a start and an end time, so at the end it will end and it will kick you out if you're not done. Okay. But yeah, otherwise it should be good. I have it set up. I will most likely have it set up where it will not tell you the score, just so that I can go back and review in case you put an answer in that maybe didn't read it right. So I don't want it to mark you wrong, but you had the right answer. It didn't accept it the right way. Okay. So look for that code in your email. If you do not take the test during your class time, you will be marked as an incomplete and you will not be able to make it up. Okay, I'm expecting that if there's a problem, you email me prior to the test, not after the test. Okay, so contact me right away if there's an issue. I will be on Google Meet tomorrow from 8:30 to 9:30 in the morning. Okay, if you have any questions, if I did not answer any of these, or if you have a specific question and you're worried that I'm not going to answer them, hop on and ask me and I will answer it. Okay? Otherwise, every Monday and Wednesday, I'll be available from 4 to 4:30. I'll be checking my email. If you want to jump on a Google Meet, we can do that too. Okay? Have a great day, everybody. Hope everybody's doing well.